Hey guys, Joe at Small Home After Prepping. Welcome to the channel. So today we're going to be covering I'm going to take a walk down my driveway here. We're going to take a look at the power company's transformer. And I'm going to explain to you guys what basically happens to the power as it comes into your house and gets to your house, how it connects to your house and so forth and that. So we're going to take a walk down our driveway here. We're actually right in the front, part of the front of the house right over here. This is you can see one of my security cameras right over here, and you can probably see through the background my concrete columns. That's down at the actual driveway here. I'll take a quick look at this and I'll show you guys as we walk down the driveway here. This is actually the driveway. This is my driveway right down over here, but this is actually a second driveway that we use here. This is actually the driveway down over here, as you see. You see, I won't walk down the driveway and show you guys, what you can probably see through the bushes over there. One of the concrete columns at the entrance. Eventually we're going to put a gate in over there, and look back over there. You can probably see the security cameras. There's two more security cameras on the pole right back over there. So this is the actual driveway right over here. But what we're going to do is we're going to actually back up a little bit here, and we're going to head down the second driveway that we have over here and take a look at the power company's transformer. And you see, this is out on the road in my house. I have two more security cameras over here that watch the front, watch the road. But here you go. This is the power company's transformer right over there, and you see the power lines coming in. That's 13,800 volts that come into that transformer, and it's single phase. You basically have a hot and a neutral, and as it goes through there, I'll bleep in a second. I'll show you some diagrams of the transformer, how it works. But that's a center tap transformer, so it's going to take single phase and split it into split phase. And so what it does, like I said, you got 13,800 volts will be reduced down to two legs of 120, which will create 240. So as you come down the pole over here, you can see they have that gray pipe, that gray cover on there. That's where your wires run down. And as you see over here, we'll take a quick look as we walk over here. So this is called a vault, okay? And the vault is basically where it connects to the house from here. It's we did this probably 2 years ago. The power company buried the lines from here, but once they connect to where I'll show you guys in a second, then I basically did the rest from there, and I had to put in the meter can, the pedestal, and all that. So let's take a walk back up. Like I said, they come down into that vault. That's 240, two legs, two hots and a neutral, and then from there it's buried over to my meter can. So let's run and take a look at that, and like I said, I'll bleep in here real quick before we do that, and I'll show you some diagrams of the transformer. Okay, you see these pictures here. We're going to talk about the one on the left first, and we're going to talk about the left side of the left picture. You see you have a line on the top, a line on the bottom, then you have the squiggly lines. That's your winding. So you have 13,800 volts coming in, and you have a hot and you have a neutral, negative, neutral basically. So then it goes through the transformer. The voltage is reduced, which they're not showing that in this picture here. They're showing more of the split phase. But as it goes through the windings, it goes through a center tap transformer. And you see we now have 240 volts, which are two legs of 120. So it takes 13,800 volts, and it turns that into two legs of 120, which combined become 240. And that's what your house runs on, okay? Your stoves and stuff like that, air conditioners and things like that. And a quick example on the left here, we see another transformer, a very small one, but it's a center tap transformer. And on the top of it, you see two red wires. That would be your high voltage coming in. Okay, that's going to be a neutral and a 240 volts like we would have over in Europe. Europe does not have split phase, so when you see 240 in Europe, you'd be looking at more of the left picture, but the left side of it, where you have one hot at 240 and then you have a neutral. Whereas here in America, we have split phase. So like I said, the picture on the right, you would have 240 coming in with a neutral, and then you see three wires coming out. That would turn that into split phase. Two legs of 120, and then you have the neutral over there. So that's what happens in the transformer, and that's how power is basically delivered to your house. It comes single phase, and then it is split into split phase. Being, again, looking at the diagram on the left, L1 and L2 with a neutral. Okay, L1 being 120 volts, L2 being 120 volts, and then we have a neutral. And here, I'm stopping before we get to the pedestal. I'm going to stop quick here. This was my temporary power pole, and this is the second way things can connect to your house. This was an overhead service, okay? So it came from the transformer directly, not down into the vault, and the wires ran overhead, and they connected to the top of the pole, as I was just showing you on the top here. You guys saw that pipe coming on the top was the riser, and then you have what's called a weatherhead. And this is it's a sub panel now. I have a bunch of things in here, lights and different things around the property, and you see it does have a grounding bridge. It has an electro grounding system in it over here as well. So this was the temporary power pole when we were building the house here, and now it's, like I said, it was connected from the pole. You can kind of see, I'm showing you the angle here, you can see where the power pole was. I think that's about 80 feet.
That connected to this pole. Now, from that transformer, it goes into the vault, and it runs about 100 and some odd feet into this pedestal. Think like 160, 170, maybe even a little bit more. And that's an underground service that comes up into the meter can. And you can see this is the pedestal that I built here. All of this I built and installed myself. The power company basically pulled their wires underground, which I had to pay for that. I think it was around $400. It wasn't that big a deal. But they buried it, and you see they came up into the bottom of the meter can. See, I'm going to get to the pipe in a second here, but now what I'm showing you is the inside of the panel here. These feeders that I'm showing you right there go through a chase into the meter can, and they connect at the top, okay, which is basically my part, which is after it's metered. The power company comes in, and they connect on what's called the line side before it's metered, and you can see this pipe right over here. That's where they buried, okay. They buried it 24 inches in the ground and came up with this pipe into the meter can, and they connected. Then from there, I connected the other side of the meter can, ran into the panel itself, and connected that. Of course, first means of disconnect, my grounds and neutrals had to be bonded, so you guys can see here that the grounds and neutrals of the panel are bonded. And you see these lugs down over here on the bottom, and I'm showing you that. That I installed, I buried myself, and that runs about another 150 feet or so, maybe more, into the panel that you guys always see over there. And you see, this is called a pass-through panel because the power comes into the main breaker on the top from the meter can. And then it goes through the bus bar. You can see my wires along over here. Then it goes through the bus bar, down into this pipe over here, connects to the lugs. And then I buried this, like I said, heading over to my existing panel, which again, you guys will hear me say all the time that that's a sub-panel.
Okay, so yeah, from there it was buried about 120 feet, I want to say, and that part I had to do. The power company doesn't do that. They pulled it to that first pipe that I showed you. It comes into the meter can over there. Everything else I did, and I had to build that pedestal. I had to put the meter can in. You see the meter can has a lock on it. It's my meter can. I own it. I had to pay for it. I had to install it, but I can't get into it. That's their wires coming into it. So they have that thing locked out. And like I said, it's buried about 120 feet, comes up into here. And then you guys have seen all this. I'm not going to start going through this lot over here because you guys have seen this. This is the point I wanted to get to. This is my 200 amp sub panel over here, and then we have circuits that go for the solar into a transfer switch. I'll include the end screen, the videos at the end, so you guys can see that. I'm not going to really, like I said, get into this because we've covered all this. This is a transfer panel over here. So this is basically how power is delivered to your house. Like I said, there's one of two ways. You can come overhead, which that's when you, again, see the power from a power pole out front that usually has a wire, runs over your front yard to the side of your house. Then you have the hub coming out of your meter can connected to a riser, which goes to a weather head. Then they connect the wires up at that point. So everything before that connection is theirs. Everything after that connection is yours. Some power companies will give you the meter can. I've yet in this area seen any that will install it. Some want you to use their meter can, so they will give the contractor their meter can to install. But like I said, I'm not aware of any power companies that actually do the installs themselves. But again, guys, that's pretty well how this works. Power comes into the transformer, 13,800 volts. It's a single phase. It is broken down into a split phase, which are two legs of 120 plus the neutral, and that's where it's brought into your home over here, and that's where you have the kind of electricity you have. You have some circuits that'll run on 120. You have other circuits that run on 240, like your dryer, your stove, heaters, air conditioners, bigger things like that as well. But they're really two legs of 120, like I just showed you guys. So, guys, have any questions? Hit me up in the comments down below. This one's a fairly quick one here. Like I said, I've been wanting to cover this for a while because we cover the electric once it's connected to your house, and we're putting in a transfer panel, and I'm connecting solar. But I really wanted to cover what's happening to electric as it's coming into your house and everything like that. So, like I said, guys, hit me up in the comments if you have any questions. And don't forget, visit our stores. We have a lot of e-commerce stores going on right now. We have a lot of great products out there. We have a lot of solar products. I mean, we have so many. Just visit the stores. I mean, we have fine diamonds. We have art. We have clothes. Really nice. Clothes and stuff like that as well. We have solar products, you just name it. So I'm going to include the links down on the bottom. Just copy and paste them. If you guys like what you see here, we're going to be getting into a lot more. If you guys follow this channel, you know I've been really tied up building these e-commerce businesses, and I'm just not able to get out the kind of videos that I want, but I'm really trying to get down to that one a week, and I'm getting closer here. So like I said, guys, subscribe, hit the notification button, and we'll see you on the next one.